Okay, good morning class. So for today lab, so we are at Lab 6, which is Lab 6 is about maximum power transfer. Actually, Lab 6 is a continuous from the previous Lab 5, which is in order to uh, do the experiment. So you need to know what is Thevenin theorem. Okay, but uh, okay, we go to the aims. So the aim is actually to simulate maximum power transfer in a circuit. The objective for this lab experiment is to verify maximum power transfer when load resistance RL is equal to Thevenin resistance RTH. So therefore, we are using Thevenin theorem for this lab. Okay. So some theory. So the maximum power transfer is another useful circuit analysis method to ensure that the maximum amount of power will be dissipated in the load resistance when the value of the load resistance is exactly to the resistance of the power source. The relationship between the load impedance and the internal impedance of the energy source will give the power in the load. The maximum power transfer is the maximum amount of power dissipated in the load resistance if it is equal in value to the Thevenin or Norton source resistance to the network supplying the power. Okay, so figure here show the Thevenin equivalent circuit. So that's mean we are converting the our circuit into a Thevenin equivalent circuit. So therefore you have V Thevenin in series with your R Thevenin, and then we have R loads. So therefore, in order to achieve maximum power transfer, your RL value must equal with your RTH value. So therefore, from power formula, so we get that PL max is equal to VTH squared RL divided by RTH over RL squared. And then when we elaborate this equation, so at the end, power maximum is given by this formula, which is VTH squared divided by 4 RTH. So therefore, we are using this formula in order to find your P maximum. So, but always remember, in order for power maximum transfer occur, so your RTH, RL and RTH value must be equal. So this is actually the aim of our objective, to ensure that your RTH value and RL value, when your RL and RTH value is equal, so you got the maximum power transfer. So therefore, you will use a Proteus in order to simulate the circuit given in this lab sheet. Okay, so pre-lab over here, you need to determine the value of RTH, VTH, and P maximum absorbed by RL in figure 1 and figure 2. And then you need to draw the Thevenin equivalent circuit for diagram figure 1 and figure 2. So that means you need to calculate the value of RTH and VTH for figure 1 and figure 2. And then with the calculated value that you got from this step, so you need to draw the Thevenin equivalent circuit. So that means you need to draw this diagram. This is our Thevenin equivalent circuit, but you need to put the VTH and RTH value. Okay. Okay, I will show you how to calculate RTH and VTH. Right. So as we know, like I mentioned, uh, in previous lab, so that this is Thevenin theorem is actually uh, theorem where we simplify the circuit, right? So and then the circuit consists of sorry, should be should be VTH, this should be RTH. The circuit for Thevenin theorem is actually your Thevenin uh, voltage in series with your R Thevenin. Okay, so and then this circuit usually connected to the load, so the load will vary. So that's why in this lab, so you need to change the value of RL, so in order to get maximum power transfer. So what is VTH? VTH is open circuit voltage, or VOC, right? So at terminal, so that's mean in order to find the value of VTH at terminal over here, right? So you need to remove your RL from the circuit. Okay, and then what is RTH? So RTH actually equivalent resistance. So, or you also can say that input resistance from the terminal, that we see from the terminal. And then these can be found by turn off every independent sources in the circuit. So when we say turn off the sources in the circuit, so if your circuit consists voltage source, so that's mean in order to turn off the voltage source, you need to short circuit that voltage source. And if your circuit contains current source, you need to open circuit that current source. Okay. So because our aims in this lab is actually to find maximum power transfer theorem, so this is what should what we expect that from the data that you measure in this simulation. So this is what we expect you can get, which is you need to vary the value of RL, okay, for the simulation. And then when your RL equal to RTH, so therefore actually maximum power will occur, right? So and then you can calculate the maximum power by using this formula. Alright. Okay, for the pre-lab, so you need to calculate the value of VTH and RL. So therefore, for figure 1, in order to calculate the uh, VTH value, right? So this is the step in order to calculate your VTH value. So as I mentioned before, VTH is actually V open circuit at the terminals. So therefore, you need to remove the RL from the circuit. So when we remove the RL from the circuit, this is what you got over here. This is the circuit that we have. Okay. Okay. This circuit is actually when you see the circuit, this is actually, we can see that at terminal here, okay, there is no more your RL. So therefore, the VTH is actually V open circuit at the terminal. So if we see here, this circuit is actually a series circuit, become a series circuit. Why? Because when the terminal over here is open circuit, then we know that current over here is 0, because current cannot complete the cycle over here, right? Current cannot flow. So automatically there is no voltage drop at 10 ohm resistor over here. So therefore we can say that VTH is actually V at is equal to the voltage drop at 3 ohm resistor over here. So therefore, by using voltage divider rules, right, so you can calculate the value of VTH. So therefore, VTH is equal to 3 divided by 2 plus 3, right, times your supply voltage over here. So therefore, is equal to 6 volt. Alright. So next, we need to find the value of RTH for figure 1. So the value for RTH can be found by turn off all the sources. So in figure 1, so the source that we have is 10 volt over here. So in order to turn off the 10 volt source, so we need to short circuit the 10 volt source. So therefore, this is the circuit that we have. So uh, to calculate the value of RTH is actually equivalent resistance for this circuit. So we see from this terminal. So from here, we see that your RTH is equal to 2 parallel with 3 ohms resistor, and then they are in series with 10 and 2 ohm resistor. So therefore your RTH for figure 1 is equal to 13.2 ohm. So please check your pre-lab with my answer. Okay. So next step is actually to find the VTH and RTH for figure 2. Okay, so this is figure 2. So we apply the same step in order to find your VTH value. So first step is actually when we want to find the VTH value, you need to remove your RL from the circuit, right? So when we remove RL from the circuit, this is the circuit that we have, right? So therefore we know that when the terminal is open circuit over here, so therefore current cannot flow due to the open circuit condition. So therefore current over here is 0. There is no voltage drop over here, right? Okay, and then this voltage source cannot supply the source due to they are not completely connected to the circuit. So we can say that VTH over here is actually equal to V 4 ohm over here, right? Because they are in parallel. So therefore, by using voltage divider rule, we can find VTH is actually equal to 4 divided by R total for 2 plus 4 over here times with your voltage supply, which is 12. So therefore, your VTH is equal to 8 volt. Okay, so next, we find the value of RL, right? So similar with the same step before in figure 1. So in order to find the value of RTH, right? So we need to turn off all the sources. So we have two voltage sources in this circuit, okay, which is 12 volt and also 5 volt over here. Both are voltage source. So in order to turn off voltage source, so we need to short circuit, alright, that voltage source. So this is the circuit left, which is from here we can find your RTH or your R equivalent from open terminal over here. So if we look from here, right, so therefore your RTH is actually 2 ohm parallel with 4 ohm, series with 3 ohm. So therefore your RTH is equal to 4.33 ohms, right? So from the calculated value given, so the next steps in the pre-lab, you need to draw the equivalent circuit. So equivalent circuit that you need to draw is like this. Okay. So just put the value of RTH and also VTH that you already calculated in the pre-lab. Okay. So we go back to the lab sheet. Okay, so this is the task that you need to do in this experiment. So which is task 1, using the chosen simulation tools, draw the schematic diagram of the circuit shown in figure 1. So RL is a variable resistor with resistance value adjusted to 5 ohm, 13.2 ohm and also 15 ohm. Use the chosen simulation software to simulate the output power across RL, right? So therefore, by varying the value of RL over here, so you need to calculate the output power across RL. So and then you need to compare this value obtained in step uh, 1.2. Compare the maximum power value obtained in step 1.3 and calculate the value. So you also need to calculate the value of maximum power transfer, and then you need to discuss your observation. Alright, so next, task 2. Okay, you need to draw this schematic diagram using your simulation tool, and then RL is a variable resistor, which is you need to adjust the value to using 1 ohm, 4.35 and 10 ohm, right? So compare the value obtained in step 2.2 and then compare the maximum power value obtained in step here, right? And the calculated value. So, and then you need to discuss your observation. So thank you guys. That's all for Lab6 input. So I hope you can by my explanation here, you can proceed to the lab procedure over here, which is task 1 and task 2. Thank you.